Hi, Algebra 1 students. I'm just going to go over a few things from your 3 lessons for this week. I'm not doing everything, but just talking about a couple of key points in here. So the first part is rate of change, lesson 10. When we talk about rate of change, it's kind of the same as slope, y2 minus y1 over x2 minus x1. So we're looking at the difference between our outputs divided by the difference in our inputs. And we see them phrased a little differently here. So our input, or our x, is t, and our output, or our y, is p of t when we look at function form. But it's just the change in these two numbers divided by the change in these two numbers. So how much did I decrease over a certain number of years, and then divide that down. So you can see some of those problems here, and I showed the work for 3 minus 0, but you don't need to do that much. If you want to just go, from 87 to 90 is 3 years, and write 3 there, and then divide by 3, that's fine too. All right, so 12 and then 13 are both looking at exponential graphs. So I just want to go over what our exponential equations look like before we look at that. So our standard form is y equals a times b to the x. A is your starting amount. That's your vertical intercept or your y-intercept, also where your graph is going to hit the y-axis. And then b is your rate of either increase or decrease, depending on whether or not your exponential is going up or down. And then x is usually time in these, not always, but a lot of these exponential equations we're looking at are time. So if I have a starting amount of $50, then our equation form is going to look like this. If we are increasing, so if we're increasing by 16%, just as an example, we have the original amount, 100%, that's $50 is 100% of what I started with, plus an additional 16%, so that's 116%, and then converted to a decimal is 1.16. So when we're increasing, we have the amount that we started with, which is always 100%, plus more. If we're decreasing, we're subtracting that rate from 100%, so the amount that I started with and 16% subtracted from that. So that would be 84% or 0.84. If you are not comfortable converting percents to decimals, most calculators have a button that does it. So I can type in 84 and hit the percent key, and it will convert it to 0.84. So in this first part, it says that Jada continues spending a third of what is left each week. So if she's spending a third, be mindful that that means she has 2/3 left. So is the equation telling you how much you have left or how much is decreasing each time? Which is why in this example back here again, 16% is how much I'm decreasing, so 84% is how much I have left. And that's why 16 isn't what goes into the equation. So we know if our b value, again, just like that example I did, if it's greater than 1, that's increasing. If it's less than 1, it's a decreasing value. And then our a value will shift our graph up or down because it's that point on the y-axis. So if it's higher a value, it's further up on your y-axis. If it's a lower a value, it's going to be further down on the y-axis. So for this example about graphs, I just tried x equals 1, and I put 1 into my equation where x went, and then found the point. So where would those points be on the graph if it's 1 along this line, and then match that up with those graphs. So if we have a smaller b value for a decaying function, that's the one that is decaying faster. In this example, we have 1/10 left each time versus 9/10 left each time. Having only 1/10 left is going to be a faster decreasing rate. So smaller for decreasing is faster. When we think about increasing, the larger number is going to increase faster. So if we look at this example, the 3 would increase faster than any of the others. All right, last one, lesson 13, more reasoning about exponential graphs, just being familiar with what these numbers mean on the graph, what they represent, what they're asking you about your situation. So for these two, when you're asked to write an equation, trying to figure out what the starting amount is usually pretty easy. That's the y-intercept. Trying to figure out what b is can be a little trickier. If I look at this example, from 0 to 1, I increased from 5 to 15. Well, what would I have to multiply 5 by to get to 15? That would be 3. So that's what tells me that my increase rate is 3. It went up 3 times as much. When I look at this one, I want to make sure that I'm not looking at these 2 points, because this doesn't go from 0 to 1. It makes a jump. It goes from 0 to 2. So that's not going to give me an accurate rate unless I also divide by 2. So I chose to go with -1 because I go from -1 to 0, and the point went from 40 to 20. So it divided in half. So my rate is half. And this last part just talks about looking at 2 functions together. How do I know which one's increasing faster? How do I know which one had more at the beginning? So higher up on the y-axis is going to be who had more at the beginning. The higher the y-intercept is, the higher the starting amount. Which one has faster growth is the one that is increasing faster. It's usually steeper. So if I look at this one, this solid line has faster growth. It's moving up faster. What does the point PQ tell us? That's where your 2 graphs intersect. That's just telling you this is when the 2 graphs were the same. So G started a little lower, but grew faster. F had more, but didn't grow as fast. So there is a point where the 2 of them met. And those are the major concepts for your lessons this week.